Hey, in this video, I'm going to show you how to add type checking and type signatures with sorbet in Ruby, and also talk a little bit about type-driven development and the benefits of using it. So we're going to start by creating a folder. I'm going to call it sorbet demo. And inside it, I'm going to create a new file called type.dd.rb. Okay, so here, I'm just going to create a simple class called person. And this class is going to be initialized with a first name and a last name. So I'm going to have an initializer, and it's going to take a first name and a last name. Okay, so I'm going to assign these. Okay, and now let's raise if the name is too short. Just for fun. Okay, so this is all that the class is going to do for now, because I don't think we need anything else. Okay, so the goal here is to be able to initialize this person. Let's say John equals person.new with John Doe. And then I'm gonna have a different class that is going to look like this. Printer class is gonna have a method called full name, and it's gonna take a person and it's going to print its full name based on first name and last name. Okay, so I don't have that printer class. Let's create it. And this class is going to have a class method called full name, and it's going to take a person as an argument. And now all it's going to do is going to return a string that says your name and then person dot first name and person last name. So I'm gonna have to expose those methods. Okay, now let's see if this works. Ruby type DD. Okay. Given 2 arguments, expected 1. Oh. Typo. Okay, so now it prints the full name. And this looks fine. But what we can do is add another level of correctness to this method, to this code. Namely, we can make sure that this argument here, John, is actually a person type. Because we can have a different type. Let's say we're going to have an actor. That's going to be a struct with name, and so now I can initialize Bruce to be an actor with its first name to be Bruce and last name Lee. So now if I use Bruce here, you can see that Ruby accepts this new type to be a valid argument here because we haven't specified, or we don't have a way to specify which types we want, unless we maybe raise unless person is a person, right? So if I do that, then I'm gonna get a type or an exception, a custom exception, and I can create a custom exception that I can raise here if I want to. But we don't have to do that because with sorbet we can add type checks. So let's see how that works. I'm gonna add a comment here that says typed true, and then I'm going to require sorbet runtime, and this is going to check the code or the signatures at the runtime. Now if I only do this and I run srb type check or srb, how is this? Oh, I need to initialize sorbet. Okay, so initialize. Yep. Okay, so I need a gem file, and I'm gonna add sorbet here. Sorbet and gem sorbet runtime. This is going to be in root development. Okay. Let's install that. And now sorbet init. Yep. Okay. Yeah, not sure what the error is, but it's working. So it's working, but it doesn't do anything because we haven't told it what to do. So to add some method signatures and to enable the type checking, we have to extend the t.sig class, and then we can use this sig helper method to define a signature. So I can say the params are person, and this person is going to be of type person with a capital P. Okay, and the method is going to return a string. Okay, so now if I run this, we'll see a bunch of errors. So what sorbet is telling us is that we said that the method, the full name method in the printer class, needs a person type as an argument, but here we're giving it an actor type. So if we change this to John, okay, and run this again, we don't have any errors, right? And if we put it back to Bruce, which is an actor class, and run the type checking again, we'll see those errors come back. And so this is nice because you can restrict arguments to your methods and make sure that your program is working correctly without relying so much on tests for types, and avoiding, in some cases where it makes sense, duck types. So Another thing we can do here is to add a signature to the initializer that says that the params here need to be strings. So f name is going to be a string, and last name is going to be a string as well. And this doesn't return anything. Okay, and now let's put this back here to John. Oh, forgot to extend the class. Extend. Yep. Okay. So now what we've done here is we've specified the types of these two arguments. They have to be strings. Let's try that. So let's say that instead of providing two strings here, I'm using a string and an integer. So now I get a type error. So you can see how this could be very useful with larger applications where you don't really know what arguments you get, or it's not very obvious from the code, especially because a lot happens at runtime. And another very interesting thing you can do is create your own types and make sure that methods only receive those kind of types instead of receiving anything that responds to those methods. So that's basically what we've done here. We have a printer class that restricts its arguments to the person class. So it explicitly says that I want a person class as an argument so that I know how to operate on that. And what type-driven development is all about is to come up with these requirements ahead of time. So instead of adding types after the fact, you think about your code before the fact. So let's just remove all code here and go through a mental exercise. So let's imagine we establish that we want some way of printing usernames, right? So I can decide that I'll have a printer class. So I can say, okay, let's have a printer class that's gonna have a public method that says full name. And this method is going to receive some arguments, and those arguments are going to be these specific types. And then I can say params here. So I'm going to receive a first name. I'm going to receive a person, and this is going to be a person class. And as you can see, this way of thinking about the code dictates how you're going to evolve your code. By knowing that this class is going to require a person class, I know that the next step is for me to create a person class, right? I don't have it right now, but because this printer class requires it, I know that the next thing I need to do is going to be to create that person class, right? So this is what type-driven development is about. Thinking about your code in terms of what kind of types you want to use. And not only that, I think the biggest advantage you have by thinking about your types is that you can eliminate wrong states in your applications. So there's a talk about making impossible state impossible by using types in Elm. And I think we can do a lot of that, not 100%, but a lot of it we can also do in Ruby by just thinking about what kind of state do I want in my application and how can I create my types such that they don't allow different states inside my app. So you can restrict, for example, the person type to have first and last name strings, and by doing that, you're not allowing any other types for first name and last name. So that's a way of restricting the state of your application and making sure that your application behaves correctly by eliminating any chance of wrong state, if that makes sense. So I hope this way of thinking about your code gives you a few ideas to test with your own code. And I hope you find this useful.